What's happening, dogs? Mr. Allen here. In this video, we are going to match each one of these four functions here to the appropriate graph here, and bonus math, we're going to do some domain and range action for each one. We're going to find the domain and range. Now, domain and range is something that people struggle with constantly. So if you're just learning about domain and range, it's not going anywhere. Make sure that we understand this from the get-go, all right? It does take some practice, though, okay? So if you're not getting it right away, it's okay. We're going to work on it. All right, so let's see here. What's the best way to go about this? I see this one here, the upside down V. That's a dead giveaway of a negative absolute value, which is my G of X right here. So let's go ahead and label this one as G of X. Now my domain for this one here, all my X values, does it ever stop going to the left or to the right? No. So you can either say that as X equals all real numbers, or you can even use interval notation. Some prefer that, negative infinity to positive infinity. There we go. That's one way to list our domain, or two different ways to list our domain there, right? Some teachers do one way or another, all right? Some even get crazy with the fancy little teacher brackets. It's a little over the top for me. This is what I'm doing. All right, now my range. Okay, I got some room right here for my range. So my range here is talking about my Y values. How high or how low does it get? Well, is there a high point here? Yes. The tallest, the highest that it ever gets is 2, and then it goes down from there, right? So we got two ways of listing this. We could say that Y is less than or equal to positive 2. That's one way to do it. Or if you're an interval notation type person, you could do from negative infinity to positive 2. But we want to include that positive 2 because it is a point on the graph. You'll never be able to include the negative and positive infinities. So depending what your teacher favors, what they want you to do, this right here is one notation. This right here is another notation referred to as interval notation, right? They mean the same thing, just written a different way. I'm going to show you guys both throughout this video. Okay. Let's see here. This one looks like a linear function, right? It is decreasing here. It's got a negative slope and a y-intercept of 3. Oh my goodness, it's k of x, dude. It's k of x. All right, there we go. Y-intercept of 3, a negative 2 for our slope. Now let's talk domain and range. So my domain for this here. So my domain. Does it ever stop going to the left? Does it ever stop going to the right? No, no. Cool. All real numbers. X equals all reals. I do like making that double R. I feel like a boss. All right, and I can also write this in the same way as we did before, negative infinity to positive infinity. How about my range, man? How about my range? I was going to run out of room there, so I'm going to do it down here. My range, does that ever stop going up or down? Nope. All real numbers again. So for our linear functions, it's going to be all reals for both, unless, there's some stipulation on there. But there we go. I don't like to memorize that kind of stuff, though. I don't like to be like, oh, linear functions, this is always all real numbers. Quadratics is always this. Absolute values is always this. Because then I start to get confused, mix things up. I like to be able to look at that graph there and make a determination from that. That's how I roll. Up to you, though. Okay. Next one here. Let's see. This is an exponential function, which means that my x is going to be in the exponent. That's f of x right here. So f of x for this bad boy. Now, let's talk domain and range, right? Here's where we get tricky. All right, domain. Does it ever stop going to the left? No. Does it ever stop going to the right as it goes up? No. So it's all real numbers. Once again, same kind of notation can be used here. Man, we got a lot of all real numbers here for our domains. What if that's going to continue? We'll see. You got to stay tuned for the whole video to find out. The suspense, I'm sure, is killing you. Okay, range. Range be our y values. How low does this thing get? Well, it appears to be approaching what's called an asymptote here at y equals 1. That asymptote is y equals 1, okay? This graph just keeps getting closer and closer and closer to it, but never quite gets there. Because if you think about plugging numbers into an exponent, whether they are positive or negative numbers or fractions or 0, this number here is never going to equal 0. No matter what I plug in for x here, this portion right here will never be 0. Plus 1, the closest I can do is I can get really close to 1, but never quite there. And that's what's going to happen. So my range is y has to be greater than 1, not equal to 1. I can never get to 1. It's always going to be above 1, which can also be written as 1 to infinity. Again, parenthesis there because I'm not including the 1 as one of those values. Yay! Last one. It's got to be our quadratic h of x, right? And that does pan out here, right? We got our negative 4 that shift down for if you're a transformations fan. I mean, I love me some transformations, right? There we go. We got h of x. All right, domain, range, we done, right? So domain, I'll just come over here. Let's draw a little line here so we don't get mixed up. Domain, does it ever stop going to the left? Does it ever stop going to the right? No, it does not. So x is equal to all real numbers. Again, same note or different notation means the same thing. Negative infinity to positive infinity. Now let's look at our range. I'm out of breath, man. All right, does it ever stop going up or down? It does look like it has a low point, right? It has a minimum here where y equals -4. It's a minimum, right? So my minimum value here is -4, which is also associated with my range. Y must be greater than or equal to -4. -4 is included here, right? If I were to plug, there it is, 0 in for my x, I'd get 0 squared, which is 0 minus 4 is -4. So that value is part of the range. We must include it. All right, the interval notation way of this is -4 with a bracket to include that -4 to positive infinity. Parenthesis, we cannot include infinity. Only Buzz Lightyear can get to infinity, right? You know what I'm saying? I think it actually goes beyond infinity, if you will. All right. That's it for this one. That was a lot of information there, guys. Domain and range, again, always a challenge for people, so really pay attention to that stuff because it never goes away no matter what math class you're in. We always talk about domain and range, and it always seems to be a struggle, so focus on that. All right. Have a great day.